So everything's going social these days. When you get a new app, new website, you're forced to use your Twitter account or LinkedIn account to sign in, right? So, hello, my name is Juan Zepeda. I'm a computer science student from Santa Barbara City College, and I had the great pleasure to work here at UCSD in the computer science lab. I worked with my faculty advisor, Z-Fang, my mentor, Ying Yu, and I worked on a social graph visualizer funded by the Army Research Lab. Now, how do I start? Well, big data. Big data actually is a term. Just recently, it's been focused on by the media and industry to represent all information out there on the internet. A lot of information is out there in these social networks like Facebook, Twitter, all these information. So this big data can be represented as social graphs, and within these social graphs there's a bunch of patterns. And they're complex, they're overwhelming, but how can we use all this information to our advantage? Well, our goal is to get the end user the power to analyze, view, manipulate this information through software, which I have created, and make it clean and simple for them. So I got on board on Project Social Viz, with basically is software that analyzes and views the patterns between people and activities by querying the social graph. So what is a social graph? Social graph is this. This data structure represented by nodes, which are the people, and the edges, which are the relationships. Now, what are some real-life applications? Well, let's say you have industry who wants to target advertising, and they have access to, let's see, back-end Facebook. They can submit a query for, let's say, all the Apple users, and in return, they would get the results clusters they nodes, and they can focus the advertising on them. And actually, this is a very cool-looking picture. This is actually not the set of comments. This is actually all the people and the relationships from December 2010 on Facebook. It's pretty cool. I can see actually Russia's not there. Also, we can use this to analyze terrorist networks. This graph actually shows what happened in 9/11. All the 4 different colors of the 4 planes that crashed. The 19 colorful squares of the 19 hijackers. So we can see visually more relationships and get more information from this kind of data. And actually the gray squares here are actually other hijackers, and we can see the links. So yes, there's a lot of graph visualizers out there like Gephi, Cytoscape, Graphics, and they all do the same kind of thing. They have interactive GUI, they have layout algorithms, they have node edge filtering, and they show you the whole graph, which Project Social Viz will implement. But I'm bringing something else to the table. A server-side interchangeable database. What does that mean? Well, you'll be able to analyze different data sets. YouTube information, LinkedIn information, and other data sets. Also, you'll be able to graph queries, which I will talk about in a little bit, compare multiple query results, which you will see also, and it's going to be social graph focused. But that doesn't mean we can't apply it to other things. So, let me remind you, we're dealing with complex, huge networks. We have millions of nodes and edges to analyze. So we have to implement a server-client model, where we have a client, your computer, your tablet, that runs the software, submits a query to a server, then that server picks an algorithm that traverses the data set, returns back a query result, and will use John, the Java Universal Network Graph Framework, to display it. So that was the back end. That's what happened in the server side. Well, what's the front, the application side? Well, what's returned back to me are this, the graph files, the graph, query, and the results. Then I have to parse them, these GML files, the graph modern language files, and grab all the nodes and edges. I have to put this into a graph structure in memory, so it's more tangible. I can manipulate it more and visualize it using the John software. Now, I mentioned the back end. I mentioned the application side, the front end, we'll see. But what type of query can you guys submit? Well, it's something called subgraph isomorphism. This is just one example. And I think the best way to explain this is by setting up a scenario. Let's say you're a boss at a company, and you have this idea to make this perfect product, but you need a team. Where you can find this team? Well, you need a professional network, let's say like LinkedIn, And in this team, you need a designer, an engineer, a tester, and a marketing person. So I have modeled all 4 people here and their jobs. Now, for this specific product, you need the team to work maybe strong in different areas. For example, the designer needs to work well with the marketing person. The marketing person needs to work well with the engineer, designer and engineer, and the tester with the engineer. And what also you'll have the ability to filter down a little bit more by using the predicate. For example, each person might have different experience, different organization, industry, and education levels. Let's say master's degree. So on the left-hand side, you see the core. This is the model we want as the boss to make the perfect product. So how do we find that here in the LinkedIn network? Well, we use subgraph isomorphism. Exactly that, and we find a one-to-one match. So out will come person A, person B, person C, and person D. Now, what's amazing about this is just that you don't get one result. Remember, these are complex networks. You can get many of these results. So this is what I've been working on for the past 6.5 weeks, sitting in front of a computer programming all day. Now, you can see that I've implemented the query. Remember, back to the past 2 slides, the design, the marketing person, engineer, and tester are visible. That's the model we wanted. Here on the right side, we have the results. Remember, it's not just one result, it's many. I've just displayed 3 right now. So you can see that it's the same model with different people. And of course, these people will have different education, so you can pick out, okay, what's the ideal group you want to build. Now on the left-hand side, right now I just have the LinkedIn network, and we'll be able to analyze that. Also, let's say we got this one-on-one match from the left side to this view number 1 here. But let's say it's so happy that Mary, in this case, Mary knew Linda. Well, is that positive to us, or is that a negative effect? Well, it depends on the situation. If it was positive, Mary, in this product, okay, we want Mary and Linda to work together. But what if we found out that Mary and Linda hate each other? So, we'll be displaying those kind of relationships. Also, here I have very simply displayed some information in the notes, but this will evolve in displaying their qualifications as industry support, industry experience, education experience, and we'll probably have a direct link to the LinkedIn website. Also below in this space, we're going to future implement some statistics about this. For example, how do we rank these results? Well, if you notice, just in this case, it's 0, but we can apply other weights to these whole graphs based on how qualified the group is. So, like I mentioned, it's not done. So, but we have future plans. Add more query algorithms, have the ability to relax algorithm. So what that is basically is, let's say on our initial model, the user, it was just a wish list from the designer work well with the engineer. We just remove that and have the ability, give the control to the user. Add a web interface. We'll add a drill down roll up mechanism. Make it open source, have the ability of everybody to contribute, to look at the source code. And we'll probably analyze, it has a possibility to be adapted to other networks, chemical networks and biological networks. And we'll integrate more data sets, for example, like YouTube. This is actually a real life graph of all the YouTube videos and how they're linked together. I'm not sure about the colors, but for example, by color coding, you can see here, this could possibly be all the Olympic videos. Let's just say that. Or on a more serious note, we can analyze terrorist networks. Of course, I am being funded by Army Research Lab. So this is actually also a real life social network. Terrorists collaborating. And for example, we see these red nodes, green and orange. But we can see about the size, by visually seeing the size, we can see how much the impact they have through other networks and how much they're collaborating. So when my friends call me up before I enter school and ask me, what have you been doing all summer? They've been playing video games? Well, I'll have the ability to say, hey, look, I built a social graph visualizer that analyzes social networks here at UCSB at the INSET program. And I was led by 2 very knowledgeable people. My mentor, my principal investigator, and I was led and inspired by these people. Nick, Dr. Jens, Virginia, Marilyn, Lee Feng Yu, and of course, the INSET program, but also my family, who has really led me. So thank you very much, and I'm